Hey, what's up everyone, and welcome back to another episode of Naked CTF. In this series, I will attempt to compromise and own a server from HackTheBox. This is my first attempt. I've not solved it beforehand or read anything about it. It's done as one take with no editing. So this could be a 30 minutes or 3 hours. Let's go. Today we are doing Ransom, which is a medium Linux box. Second medium in the Naked CTF series. The last one was medium as well. I got a little bit traumatized by that. Just because there was some discrepancies between what I was seeing and how things were done, and maybe the box had moved away from its baseline. So yeah, it was an interesting one, that's for sure. And what's it called? Ransom. So let's just get ourselves set up as normal. We got a TMUX session running. We've got our notes created from templates. And if I can find it, there it is. Okay, so let's get our recon underway. And there we go. Straight away, 2 ports, 22 and 80. So 22 TCP is likely going to be SSH. 80 TCP is likely going to be HTTP. You can always update that if we find different. But what I'll do is just go and plug the results from Nmap into our note-taking here, and not a whole lot, only 2 services, which is great because some of the more recent boxes that I've done have been like 11, 12, 13, 14, 15 services. And here we go. So it doesn't look like it's doing a redirect to a domain or anything like that, so we don't need to worry about DNS. So the first thing that we're going to do is, casual browse of website, and then we can't do any vhost enumeration because we don't have a domain. So we're going to do dir and file enum, etc. So we know it's Apache, we know it's Ubuntu. Both the banners for HTTP and SSH confirm that. So let's grab the IP and http://boxip. Straight away, we get a redirect to /login, ecorp incident response secure file transfer. Okay. Please enter the password provided to you in order to send files to the ecorp engineers. Password? Nope. Okay. That would have been too easy, wouldn't it? So let's have a look at the source code for the page. All fairly vanilla, created with Bootstrap, of course. Yep. Some login form action to submit. So submit function get API/login. Let me just make this a bit bigger for you. Password, it takes it from the DOM, and if it's successful, replace it with /. So I think the website root, if you're successfully authenticated, is here. But if you're unauthenticated, it's going to send you, yeah, we even see a flash of the homepage, but then it obviously detects that you're not authenticated. So yeah, I think, we don't really have a lot to go on here. The form itself posts to itself, so it posts to /login. There's a password for field and a submit button, and that's it. Nothing else that's really interesting, just some boilerplate jQuery and JavaScript that's used for the Bootstrap template, etc. So let's just try some payloads here. One. Nothing. Okay. Let's throw this into burp. Yep. Okay. Test. Set as the password. Don't save. And if you go to the proxy, delete all these from another. Okay, there we go. API login. So we have a submit, or we have a get Okay, so when the form is submitted, which is here, so the ID is login form, and what we actually have is some custom JavaScript here that's bound to the submit button. So what this means is when the login button here, which is here, is pressed, this JavaScript runs in the browser. And what that's going to do is a API call to, it's going to do a GET request to API/login. So that path would be API/login. Okay. And it's going to send one field, which is the password value. If it is successful, so it's an AJAX request, which is why you see in burp here that the requester or the user agent is XML HTTP request. So it's an AJAX request. And it passes the password as a GET, not a POST. So it posts to itself. No, it doesn't post to itself. When the submit button is pressed, this code fires, and then it does a GET request to /API/login. So if we actually fire up the browser here, fire up the developer tools, and then we do this, we should see a request. Yeah, there's the GET request. There. So Laravel session, alright, so we know likely Laravel framework, okay. And while we're doing this, let's get our directory enumeration going. So it's going to be buff minus u is going to be HTTP IP fuzz, and word list, we'll just start with user share word lists, sec lists, discovery, web content, and then quite like this big .txt word list. Let's let that go, see if we find anything interesting. So the cookie is coming from the Laravel framework, which is, you know, somewhere in the middle of all of these requests. And we send an XSRF token, and that's about it, really. So what do we want to do here? We probably want to just test that we can, this is the response from the API. So we want to test that we can just use this session cookie without having to worry about XSRF tokens. Send to repeater. Send. Invalid password. Now if we change the this cross-site request forgery token, do we get an error? No, it does say it seems to ignore this particular token. I would imagine this has to be valid, but yeah. So, right. What should we try? We'll let this finish. And then we need to figure out what we're going to do. I think we'll start with SQLi payloads. Now, it doesn't seem like this would have a SQL backend. Like, it's not like a typical username and password. So, yeah, let's just fiddle around with it. So we'll change that to a single quote. Invalid password. Change it to a double quote. invalid. Doesn't give any weird response or anything. Register is /500. Register. Yeah, okay. So it's definitely Laravel. I recognize this. We might get some info from the stack trace. No, not really. It's just from the middleware that Laravel provides. But index.php, run the application. So they got debug turned on, which is not great. So this is the root of the application. This is moving all through the middleware, rackware type stuff. But I don't think we're going to see any actual application code here. Convert empty strings to null. Okay. What's this edit? Transforms, pipeline, kernel, router, encrypt cookies. And it's a lot of code that executes for one single request. Pipeline sharers from session. All right. Verify CSRF. Okay. But there's no actual application code, which is a shame because it would give us some, interesting stuff to work with if we could see some snippets of the source code. So we know from that debug page, we've got PHP 743, Laravel 883.1. Debug. Okay, stack trace. All right, so we kind of had to look through all of that. Register is not good. We go here. Let's just have a quick look at that. Clear all this out. Go to the root web page. So we get a 302 get. Okay. 302 redirect, I should say. All right. Let's try a few more SQL payloads, just some simple ones. Let's go. Bad requests. Okay. Set 20. Set 20. Invalid password. Yeah, so if this is not URL encoded, it's going to chuck a wobbly. It'll give us... Yeah, actually the Apache server will catch that before it even hits the application. Nothing interesting in here. We did get register, which gave us this 500, which gave us some more information about the application itself. Robots.txt. Okay, it's just making sure it doesn't get indexed. Not that it should ever be exposed to the internet. I think we might fuzz the API endpoint. Because that could be interesting. So we'll do the API path and then web content. Now, where is the API? Yeah, API. API actions. Lowercase. Nothing. Thought it would have found API/login. Maybe we need a better word list. No, that didn't find login either. API seen in wild. Seems to be a bit of a longer list. So I'm going to assume at this point, given the lack of other services to enumerate and everything else, that our goal is to basically break into this web application somehow. And we'll, I think, put our efforts into that because the only other service is SSH. Rarely in a CTF are you trying to compromise SSH directly. It's more there as an entry point once you develop some credentials. But let's see. I mean, this is a medium box, so we shouldn't be, you know, too presumptive. Let's just check Apache itself. Okay, this is how I like to do it, is to go vendors, then search Apache, and then search, products, and search for HTTP server, vulnerabilities 291, and then what version were we on? 2441. 2.4. And let's filter it by CVS scores greater than 8. Two, 441. Okay. Until M, we don't care about. We're not on Windows. Map URLs to file system locations. Code execution or source code disclosure. I did have a look at this. It's like a HTTP smuggling request. But it has a bunch of like preconditions that need to be in place, like mod rewrite and that sort of stuff. Mod proxy. Most likely not using mod proxy. Request smuggling. Smuggle request to the AGP server. Yeah, well, we don't have a front end in this case. It's not like we have an Nginx fronting the HTTP server or the Apache server. May not send X forwarded for headers. Yeah, but we don't think that that's being employed as a control or a security measure. Crash or disclose information due to a read beyond bounds, and no code distributed with the server can be coerced into blah blah blah. Out of bounds, etc. Limit XML. Body requests. Close inbound connections. Yeah, again, smuggling. Configured by alias-like directives. These directives are not protected by the usual default configuration required or denied. Well, we'd assume that, you know, the Apache config is pretty vanilla. Only affects 2449 and 2450 are not earlier versions. Okay, so we can disregard that. URI path can cause mod proxy to request an origin server chosen by the remote user. Yeah, okay, cool. 240, 246, specially crafted session header could cause a heap overflow. Okay. I mean, the fact that it's not kind of being tagged as this known exploited 2418 use fuzz network input to HTTP2 session handling can be made to read memory. Okay. 240 to 2429, that's not us. 234 4237, it's not us. 42426, it's not us. 42426, that's not us, that's not us. 2423. That's fixed in 2423. Public exploit. Mod IS API 2214 and 23x before 237. That's not us. 2824. We're not using SSL. Mac OS, nope. Mod proxy 125. Okay, now we're getting back into the like 26, 27 years ago. So I doubt. Okay, so maybe like unlikely there is suitable Apache HTTP CVE. What else? Let's have a look at those API word lists. User share word lists, sec lists, discovery, web content, web content API, like actions. We probably want endpoints, don't we? Where's login? No login. Okay. There it is. Okay, I think that's the one I'm going to use. API endpoints res. API endpoints res txt. Okay, now we're turning up some stuff. Ooh, Swagger. Unfortunately, that's redirected. Because that would just give us like API docs. /API/Swagger. Yeah, redirects us. Redirects us nowhere. API v1. Redirect v2. 404. v2 option. Redirect docs. I mean, these are all kind of dead ends. Okay. So if it was a SQL payload, I would have thought that we would have got something fairly quickly. I'm just going to fire up this tool. From text. So we really just want to URL to encode. Encode. No. I used this a little while ago and I quite liked it, so I'm just not sure how it works. URL encode. Input is that. Actually a lot less painful than the encoder within Burp itself. So take that URL encoded and we're going to Burp. Put that in there. Invalid. Okay. I mean, if the point is, if it was a SQLI, I would think that we would get some sort of error that user doesn't like either. So let's just try a few more of these. This one's always good. Yep. Copy that. Put that in here. Send it. Yeah. Okay. So unlikely to be SQLI. Let's think about XSS. I mean, unless it's like a reflective XSS, which is going to nab some details from someone else. A blind XSS is of no use because, like, I'm the only user. It's not like there's other people logging into this, I would think. So let's just have a look at hack tricks. Just for some other ideas. Yeah, bypassing PHP comparisons. If equals is used in PHP, there are unexpected cases where the comparison doesn't behave as expected. This is because equals only compares values transformed to the same type. If you also want to compare the type of compared data, you need to use triple equals. And I have come across this before, this type juggling kind of thing. But I need some examples of how I would construct a payload. PHP can compare instance strings. For example, when PHP needs to compare the string 7 puppies to the integer 7, PHP will attempt to extract the integer from the string, so this comparison will evaluate to true. Okay. Let's see, the PHP code that handles authentication looks like this. Then submitting an integer input of 0 would successfully log you in. Let's try it. 0. Send it. Invalid. This vulnerability is not always exploitable and often needs to be combined with a deserialization flaw. For the reason for this is that post-get parameters and cookie values are for the most part passed as strings or arrays into the program. If the post parameter from above is passed into the program as a string, PHP would be comparing two strings and no type conversion would be needed. And 0 and admin, yep, so 0 the string versus 0 the int is obviously different. However, type juggling issues can be exploited if the application accepts the input via functions like JSON encode or unserialized. This way it will be possible for the end user to specify the type of input passed in. Consider the above JSON. The first one would cause the password parameter to be treated as a string, whereas the second one would be interpreted as an integer. Avoid typecasting before comparison. Well, we're not passing it as a JSON, are we? it a case? No, because I assume at this point we would pick up a new cookie, right? Okay. PHP type juggling examples. Type juggling. Loose comparison 2 equals, strict comparison 3 equals. Okay. False equals null is true, null. Aye. Magic hashes. String hashes to integers. Okay, that's if you want to use. Yeah, okay. We don't need to do a malicious cookie, but the concept is the same. Null. False. I mean, these are just going to be treated as strings, aren't they? True. So it's getting the response, which is essentially this. If the body contains login successful, redirect to the root. Else, display the invalid login message. Do we want to try and brute force it? Let's try. Okay. Hydra is going to be all we need. I don't think I've got any good examples of Hydra. Hydra HTTP. I've done it before, just didn't capture the notes. Okay. Yeah, this is kind of like what we're looking at. Second address. First address, second address. Okay. Man, rock you is a long list. We don't want to do a post, we want to do a get. We don't need basic auth. Get form root, so that would be API slash login. Okay, so the syntax is URL segment, get string, I guess, and then this is the negative case. So okay, let's do, we don't need a login file, we need a password file. User shared web lists, set lists, passwords. 500 worst passwords. Let's do 10,000, which may be excessive. Get, and then we want HTTP IP slash, no slash. And we want HTTP get form. The segment is going to be API login, colon, password equals, then the substitution, pass, colon, then the negative case, invalid password, invalid password. All right, let's try it. Oh, okay. So I think we use, yeah, the syntax has changed. Oh, Hydra. Man, Hydra. HTTP get. Get. Okay. Service to attack. Hydra service. Help. Yeah. That's right. So we want okay. HTTP get form. No, it's not it. Module colon slash slash. Module colon slash slash. You use www.example.com module. Okay. Oh, so we don't need the HTTP. And then we need HTTP, the module itself, which was HTTP get form. I need at least the L, capital L or C. Let's just give it a dummy login, I guess. Admin. There we go. 16 valid passwords. What? I'll be right. No, it's not right. 10.10.11.153 API login password equals pass. Password equals pass. Hydra HTTP get form. Syntax for HTTP. Dang it. Okay. Do we get some hints? I want to pursue this a little bit more. I doubt this box would have a brute forceable password. Well, I don't know, it's very presumptive, but how do we pass a 0? Maybe if we do it as URL encoded, 0 to 0. Like, how do we get a 0 into magic number? 0 E But how do I get a integer in there? That was helpful, but not quite. I need more examples to kind of really start to try and mess with the payload. Yes, okay, so that's what I'm assuming, is that it's a loose comparison rather than a strict comparison. Yeah, okay, that tells you what not to do. I'm wondering if it's comparing it to a hash. So I'm just experimenting with sending some fake hash of different lengths. See, I think this is just where the server has failed to keep up with the requests. Yeah, too many attempts. Okay, so we're being throttled. I wait a little bit. Okay. Might have to wait a few minutes. Right. Let's have a look at the hints. Laravel. Get. Oh. While the endpoint only accepts GET requests, it will still read the password parameter out of the body if the request is in what format. Okay, so we got to mess around with this. Ah, okay. So let's just do a GET. And then in the body, let's do password tests. Should be the same. Okay. 0. Password field is required. Where is it? Password equals tests. So will it accept a post? Get and head. Okay, head, HTTP head. is the structure of HTTP head? General HTTP header format contains colons, separated name value pairs in the header field. Okay. Man, it's been a long time since I've done this. So is it as simple as head, then pass tests? Nothing. Oh. Still waiting for a response. Connection closed. Timeout. Unprocessable. Password. Test. HTTP head method requests the headers that would be returned if the head's request URL was instead requested with HTTP GET. For example, if URL might produce a large download, a head request could read its content length. Uh-huh. Oh, maybe it is post. What other options are there? Password equals var. Supported methods get and head. It will still read the password parameter out of the body of the request if it is in what format? Oh, content type. Oh, okay. So it's still GET, but it's JSON. I got it. Yes, here we go. So we go GET. It's get back into a working state. Password equals test. Invalid password. Fabulous. And then we change the content type. We add the content type in this case to be application JSON. And then we do password test close invalid password. Okay, let's send it without a quote. 0. Okay. Oh, let's get rid of this. Password field is required. Password. Ah, there we go. We've bypassed it. Oh my god. Does it work with just any old string? Nope. Must use 0. Far out, Brussels sprout. Okay, so. Does that mean our cookie is now authenticated? Yeah. Because the cookie in our browser and the cookie we're using here are the same. So the cookie is obviously flagged on the server side as being logged in. All right. User flag. Wonderful. Oh my god, I'm really enjoying this. What is the title of the first file sent by client? I have no idea. Oh, file sent by the client. Home directory.zip. Home directory.zip. All right. Let's do it. Oh man, that's exciting. So let's download this encrypted home directory. So it's called uploaded file. So we're going to go cp downloads uploaded file to here. And we're going to do unzip uploaded file. Okay. Right, so we need to crack the zip password. We need to brute force the zip password. I think John Ripper zip file. Again, do I have this in my notes? Zip, yeah. So we do zip to John uploaded file zip.hash. Okay. Okay. And then we do fcrack zip minus v minus u minus d minus p user share word lists rock u and then oh no. Okay, let's try John first. Word list user share word lists rock u. Can't figure out the hash type. Alright, I think that's why I went back to fcrack. V minus U minus D minus P user share word list rock U uploaded. Not encrypted, skipping. F crack zip. Oh. So unzip uploaded file. There's an SSH key in there. Private key there. So zip.hash. What did John say? John to zip. PS check, PS check, PS check. Okay, she's not encrypted or stored with a non-handled compression type. PS check. Short file. PS check. TS check, TS check, TS check, TS check. Zip encryption TS check. Is that the algo? I'm going to use the RockU list. Options, password files. There's a no switch. Just like that, huh? Oh, okay. So it's complaining about the fact in RockU there's a whole bunch of different hash types and everything else that it's seeing. Okay, I think that's the case. All right, let's just use the default, see if we snap it. Loaded one password hash. No, I'm not satisfied. And John. Word list. Word list. Yeah, because if I just pass it, it's going to try and... yeah, okay. If I pass it without the right switch, it's going to think it's another set of hashes or something that needs to attack. Modes. Mode. So it's minus word list. Minus word list. User share. Word lists. Share. What is going on? Share word lists. Rock view .txt. Done. Is that it? 2 para? What do we have to do? John, go password. Word. John, show, zip.hash. Why is rock you so fast? Two 559. Identify zip encryption. Linux. Z command line. Z? Yep. 7ZL minus SLT. 7ZL minus SLT. Uploaded file. And then we want to look at the method. Okay. Zip crypto deflate. Zip crypto. Zip crypto. Oh, store. Okay. So let's make a note. Non-crypt files. It's going to be .cache zip crypto zip crypto this doesn't have a method. Oh yeah, store. So .ssh zip crypto so it just seems like the two folders. Well, it is. I think it's using generative passwords. It's not actually using the word list. Okay. Oh, it's not the zip crypto. 7Z LSLT, that's what I did. Oh, zip crypto deflate. Zip crypto deflate. Right. Zip crypto deflate. Zip. Fcrack. Zip. My PC fans are going absolutely bonkers at the moment. Yep. Oh. Yeah, so John is just generating strings that get longer and longer and basically brute forcing every... So let's find out why fcrack is not playing nicely. Skipping. 8 file maximum reached. What's going on? HackTheBox. Okay. So it looks like we just should target a particular individual file. Zip file to crack. Okay, let's have a little read about fcrackzip. So minus D is dictionary, yeah. Minus V is verbose. Minus U and minus P. So why have we got P and D? Yeah, we don't want P. Minus D pasta text. Let's drop that. Mate, that can't be. User share word lists rock you WC minus L. No, can't do it that quickly. Come on. Zip crypto is vulnerable to a known plain text attack. Leaker posted zip with full password. Leaker posted zip without locker without password. Grab some known plain text from the second, and you can crack the first with BK crack. So we would know that in here, something like IDRSA or IDRSA pub, SSH RSA certificate example. We've got the begin certificate header, right? Just show me an example. Certificate. Just going to take a guess at this. So we want to do print f begin cert haha std haha xxd. Okay, so we got some bytes. And then BK crack. BK crack. Sudo apt install BK crack. Right. Need to download this. BK crack. Crack legacy zip encryption. Okay. Sounds cool. Just a sec. Right. Oh my God. So, do we need to build this? So what we want to do is, first of all, let's make the in here. Loaded to here. Let's move our known bytes into here. Then we're going to do 7z a minus mm equals deflate mx9 uploaded. Aha. Oh, okay, so we put that data in there? I don't know. Okay, so we added that file to the contents of the archive. Do we have a bin? No. readme.md. Oh, there is releases? Oh, okay. Ah, okay. That would make more sense. So CP download BK crack to here, tars z xvf BK crack, CD BK crack. Let's move. Let's move this stuff. Loaded to 170 into the binary directory. Let's move the into the 170. Okay, I think we're getting there. Bear with me. BK crack. Right. So it looks like we're never going to brute force the password via John or something like that. Right, so now we run bkcrack minus C. Our original what is the minus C? Yes, this is a file that we want to grab. So minus C uploaded file minus lowercase c dot ssh id rsa ssh RSA. Okay, that's the original. So let's move uploaded file to uploaded file dated. 7z lists uploaded file. Yep, we got our haha file in here. And then, so let's then copy the original to here. And then let's move that to uploaded file orig.zip. That's it. Orig.zip. Okay. Now we know clearly which is which. Yeah. EK crack minus C. This should be the original. Minus C file that we want is going to be .ssh id rsa. Minus P is going to be the updated. And minus P is going to be that file we created. Haha. Oh my god. Okay. We're 1 byte short. So let's do this. Let's rm the uploaded file updated. Let's vim. Let's move haha to seed. Vim seed. I thought it had to be something, a string that was expected in one of the files, but just appears it can be anything, right? So we'll just make that a bit longer. Then we go back a step and we do 7z seed plain texts. .zl uploaded, make sure it's in there. Huh? Alright, okay, we screwed this up. Let's get a fresh copy. Here. Let's do this. Let's check. The file is in there. Yes, it is. Now let's do to updated.zip. Let's copy a fresh one over here to orig.zip. Okay, I think we should be good to go. Try it again. So BK crack seed updated.zip orig.zip. All right, seems to be running. 11 bytes of known plain text. And then eventually we get this hex key. Then what do we do with that? Oh, it actually writes the archive out again. Beautiful. This. Then why are they cracking the original password? Oh, okay, it's a different set of options once you've got the key. All right, we'll just let that go. Might take a few minutes, so sit back, enjoy the music while we wait for this to hopefully be successful. It doesn't have to get to 100%, could happen anytime. Just thinking this might not be the right option. So in the example here, where does it get the ciphertext? Empty locker readme. Is that the contents of a file? Not looking good. Not looking good. So if minus lowercase c with the entry cipher being the ciphertext. Entry cipher. BK crack ciphertext. Uh-oh. Yeah, I think we got this wrong. So let's walk through the example here, because I think, yeah, this has got to be not a file path, but an actual string that's going to appear somewhere. And I guess what it's doing is running zip crypto against that ciphertext and then trying to find it. And yeah. So yeah. Okay. Let's try this again. So let's use this. So what we want to do is echo -n into plain.txt. Now we want to run bk crack -c orig.zip -c, where we would find it, which is, and then we just want to pass the fragment plain.text. First of all, let's do -l bk crack -l orig.zip. Okay, so we just make sure that that name is the same. Let's do the pub. Oh, hopefully this works. Oh, it's not going to work because it's deflated. Dang it. It's encrypted but store. What is this file? 12 bytes. Contents. Okay. The easy way, stored file. Let's assume the zip file did not contain an uncompressed SVG. Then to guess some plain text, we can guess the first bytes of the original advice.jpg from its extension. The problem is that file is compressed. To run the attack, one would have to guess how those first bytes are compressed, which is difficult without knowing the entire file. In this example, this approach is not practical. It can be practical if the original file can easily be found online, like a DLL. Okay. Okay. Do I have that file? Sudo as admin successful. Yeah, there's nothing in there. BK crack -L arrange.zip. Is that why we add zip and store? Okay, I think that's why we go through the okay, I see. So that's separate zip. Yep, okay. Grab some known plain text from the second and you can crack the first. But we still don't have right. Okay. zip with password. Zip without locker, without password. Okay, so I think this is unpassword protected, but it's a subset of this, right? So how would we identify some plain text? So that's a directory, nothing, 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 nothing. Oops. So it's stored but not deflated. First bytes from its extension. Problem is this file is compressed. To run the attack, one would have to guess how those first bytes are compressed, which is difficult without knowing the entire file. In this example, the approach is not practical. It can be practical if the original file can easily be found online, like a DLL file, for example. So then one would compress it using various compression software and compression levels to try and generate the correct free text. So that's variable. I mean, bash RC on Ubuntu is probably going to be reasonably consistent at the beginning. These are all... Well, we do have the... yeah. Yeah. Okay. Effectively, what we'd have to do is 7-zip add how do these guys do it? I mean, they have this string that they know exists. No, they know this file exists, and then they know that that's a string within it. So, look, I'm going to jump into the walkthrough here for a hint, because I could be here trying a lot of different things. Ooh, password true also worked. Okay. Bash. Log out. Yep, that's probably consistent. Okay. Bash. Log out. Here. Then zip unencrypted. Zip add bash. Move. Zip unencrypted. Zip dash logout. Unencrypted.zip. Yeah. That's it. We were close. We were close. Didn't really think about bash logout. Huh? Okay. Expected plain text. Got nothing. Is that because it needs to be in quotes? Minus E. Oh, we renamed it. What I was thinking was that I would grab something like bash RC and then do a bunch of tests to try and encrypt, to zip that, and then, yeah. But I don't know, it was a bit more brute force than I would have thought. So, do we have... Yeah. Decrypt. MV unencrypted to decrypt. Decrypt. Unzip unencrypted. Huh? But I only got what? Okay, didn't output. We have the key. So we're going to do bk crack -c orig.zip. Key is going to be that. And then -u orig pass.zip pass. Unzip orig pass.zip -d uploaded pass. We have it. SSH. So it looks like the user is HTB. SSH -I ID RSA HTB at IP. We're in. Cool. Cat user.txt. We've already got that. HTTP at ransom. Right. Sudo -I L. We don't have the root user's password. Sorry, we don't have HTTP's password. Okay, let's poke around. etc password grep message. So it's just HTTP and root user. Nothing in here. That we haven't already seen. Let's find the web app. That's the default landing page. Less etc Apache 2 sites available. That's enabled. SRV prod public. Prod public index.php. Now, Yeah. Laravel apps have config, which usually has secrets. App.php. Instruction. Nope. Fourth. Database. MySQL. Forge. No password. Which one is it actually using there? Default is MySQL. What? LAN-TP. LAN-TP. It's me on SSH. That's the listener. Nothing. Whoosh. All right. Given the time, I'm going to look at a hint. SRV prod, yeah, we found that. Well, I never would have thought of that. Okay, so this is the actual password that we bypass with the type juggling thing. So we do Vim. Yeah. Okay, Vim. App. Controllers. App. HTTP controllers. Auth controller. This is the custom logic, right? Where it will basically this slash API slash, yeah, so let's do this a little bit smarter. So if we looked at routes, web slash login, auth controller class, yeah? We would have been able to open up the auth controller. This is actually where the application code is written. And it would have been UHC March Global PW. If I had to guess, that is going to be the root. There it is. Cool. All right. Cat root. Done. Oh. Shared with the hard-coded, yeah. Cool. All right. We are done. That was really fun. Medium seems to be on a bit of a spectrum, but that's, you know, what it is. I really enjoyed like working through the type juggling bug. The plain text attack on the zip was a little bit unusual, and, you know, again, I think if I'd spent another hour or so on it, I might have got there in the end. But given it's late in the evening and I've been at this for 2.5 hours, I thought I might just wrap it up and take a hint, which has been great. But I'm loving these medium boxes, definitely much more of a challenge. Not that the easy boxes were not a challenge, but it's good to mix it up a little bit. I'll figure out what comes next for the next episode, and yeah. Otherwise, it's been a lot of fun, and if you stuck around to the end of this video, thank you very much, and have a great morning, afternoon, evening, or nighttime, whatever time it is for you, and I'll see you in the next video. Bye-bye.